Okay, so Chapter 4, Population Dynamics. Our objectives are to describe the characteristics of populations, understand the concepts of carrying capacities and limiting factors, and describe the ways in which populations are distributed. The main idea is populations or species are described by density, spatial distribution, and growth rates. Characteristics of populations include the population density, which is the number of organisms per unit area. How many are packed into a given space? When we think about population density, we think about like the world population, as you can see here on the map. The darker the area, the more concentrated you have of human population. Just looking at the United States over here, you can see that the eastern side of the United States is heavily populated. That's we have the highest population density. As you move out west, it becomes more sporadic. You do see clumps of them. Those are major cities. What's limiting, like those limiting factors we talked about before, many of us from living out there in the west, is water supply. So we got to have enough water in order to live there. That's essentially the same thing as in the desert. As you go down towards the southern United States, southwest, you can see there's not very many cities. But again, on the eastern side, we have lots of rivers and streams that furnish all that water to people. As you look across the globe, you can see that there are patches missing in certain areas. As you look at the continent of Africa, you can see there's a big wide gap where there's nothing there. That's the Sahara Desert. Again, another big resource that's limiting human population expansion in the area is water. You look at Australia, it's actually not as populated as you might think. The majority of Australia, believe it or not, is largely desert. Okay, as you look up in the north part of Russia, there's no population density up there because it's so cold. So again, people are confined to the places they can live based on the limiting factors. An interesting concept is how populations are dispersed out. So dispersion is the pattern of spacing of a population within an area. How are the individuals arranged, throughout the given space? Are they uniform, clumped, or random? So let's look at the pictures on the next slide here to kind of identify what we're talking about here. Here you can see that we have our clumped pattern, spaced, and random. And they've kind of given an example of what those might be. So clumped, think of like minnows in a stream. When you see the minnows in the stream, they're kind of swimming in numbers. Numbers usually mean safety for them, but they're in little clusters. Okay, so you got the little clump part. Then you have spaced would be like hawks. Notice how they're evenly spaced out. And the reason for that is because if there's too many hawks in a given area, there's not enough food supply. So again, another limiting factor is food supply. They have to evenly disperse themselves out. And then, again, if they get too many in one area, they could fight for the territory. Random would be like dandelions. Again, we all hate dandelions, but if you have that dandelion that has gone to seed, it's that white top, and you blow on it, it just randomly, they float away and into your yard anywhere and everywhere, and they just scatter throughout. Okay, so when you think about the human population, which one are we? Take a minute to think about this for a second. When you consider the possibilities of what we do, we're a little bit of all of them. So we do clump together, typically in communities, towns, cities, things like that. But are cities not kind of spaced out? So there's, maybe 20, 30 miles in between a city. Sometimes cities grow and encompass other ones, but they kind of space themselves out based upon resources and availability. Sometimes they're just random too. They can be randomly scattered throughout the United States. But again, they're usually randomly scattered throughout the United States based upon resources. So we do some interesting things. And some people may prefer to live in the city, while some prefer to have their own space out in the country. And some people just buy a place wherever they can. So humans, we kind of got this weird arrangement. So what exactly determines the range of a species? It ultimately comes down to adaptability. Organisms that are able to adapt to biotic and abiotic factors will have a greater range, which that ultimately means that they can tolerate that range of tolerance. They have a good range of tolerance to move out to other areas. Organisms with a narrow tolerance range will be confined to areas that meet their tolerance requirements. So if they could only survive in a temperature of exactly 72 degrees Celsius, that is a very, very specific and limited habitat. Okay? And Charles Darwin has a quote here that says, "It is not the strongest of the species that survives, nor the most intelligent that survives. It is the one that is most adaptable to change." If you can withstand the changes of the environment, of the ecosystem, you will be the hardy species that will survive 1,000,000 years. So having the ability to change for a species is going to make that success and then have them create more and more offspring. This is another interesting concept of limiting factors. It's called carrying capacity. It is the amount of individuals that an area can sustain. Too many, then it could be overwhelmed of great numbers. So it could be a problem with food sources, disease, things all like that. Carrying capacity is determined by limiting factors, usually one limiting factor at a time, that will have the most or greatest impact on them. If there's only enough food for 100 cattle in the field, then the carrying capacity is 100, and the limiting factor was food. Just like if you ever rode on a boat, okay, every boat has a carrying capacity. So it says you can only put 9 people in the boat. This boat over here in the photo, as you can see, has reached its carrying capacity and now exceeded it. It is so exceeding that all those people on there are actually causing the boat to ride sideways, which means it could capsize and then kill everybody. So this is a problem. Okay, too much weight on a smaller boat can sink it. And this is why they have carrying capacities. So every ecosystem has a carrying capacity for every species that exists out there. But there are factors that determine how many can be in that area. These are density factors. So density-dependent factors does depend on the number of individuals per unit area. These are often biotic or living factors. Okay, things like predation, how many predators are in the area. That can determine how many rabbits can live in the area. Diseases. If there's too many rabbits, they're going to, again, probably be weaker because of starvation, and they're going to be able to transmit diseases easier because they're in close proximity. Parasites start to show up and be transmitted from individual to individual. Competition among water resources, food resources, all those things can cause problems for that individual. So these are usually, again, biotic factors that cause the problems. There are also density-independent limiting factors, and this does not depend on the density of the population. Usually these are abiotic or non-living factors, things that can happen in the environment. So things like drought, flooding, extreme heat or cold, tornadoes, hurricanes, wildfires, you name it. Okay, all these factors can play a role in populations and determine how many can live there. If the area was notorious for fires all the time, well, it's going to destroy a lot of the habitat, which again is going to limit how many individuals can live there. If it was just tornado after tornado after tornado, those poor bunny rabbits are just going to be swept away and there's not going to be hardly any left. So, again, density independent limiting factors. So this limiting factor is like, could be a predator, and it's a predator-prey relationship. And we kind of looked at one of these before, but this is a type of graph you'll most likely see on the EOC. You can see on the left here, it says the number of moose out there. And it's got the population go from 0 all the way up to 2,500. On the right side, they have graphed the number of wolves. Okay, so 0 to 60. The wolves are the red line and the moose are the yellow line. And they tracked the populations from basically the 1960s to the 2000s. And if you notice the interesting trend, and the interesting trend is that you're seeing this intersection that they cross. And then when one goes down, the other one goes up. And then we see it again and again each time. So this is pretty typical of species that have predator-prey relationships. And what's going on is that as one declines, the other one increases. So again, they're limiting each other based upon what's happening. So as we look, we will see that the wolves starts off pretty high and the moose population is fairly low, which again, the numbers are slightly different. But as the moose population is rising, the wolf population is going down. And the reason why is The previous, in 1965, the wolves were starting to starve. So they weren't getting enough food, they became weaker. But then the moose population started to increase a little bit. Now there's more available food. The wolf population shot up really, really high due to the abundance of moose out there. They had all sorts of puppies and whatnot, and that's reflected in the 1980s. But then, in the 1980s, we see a massive drop-off of the moose, which then led to a massive drop-off of the wolves. So all those new wolves, those young wolves that were just being born and starting to grow, they starved. They died. So, end of those wolves. But then, the moose population, they capitalized on the less predators, and they had a boom year, and they shot up. So what do we expect to see? This constant crisscross of predator-prey relationships. This can be seen with a lynx and that hare that we talked about, bobcats and rabbits, anything, you name it. Okay, there'll always be this predator-prey relationship. So just keep that in mind about predator-prey relationships, that you're going to see this up and down. And if they ask you to make predictions, you're going to see that one will rise, one will increase. So reproductive strategies, though, moving forward, the R strategists usually are smaller animals, fruit flies, mice, locusts. They have a very short lifespan. Okay, lots of offspring are produced because they know that most likely a majority of those offspring aren't going to make it. It's kind of like a shotgun effect, that hopefully one of them will make it or hit the target, but in the end, many of them perish because they are usually prey items and get eaten up by other predators. Controlled by density-independent factors, K strategists, usually larger organisms, elephants, bears, whales, humans, we have less natural predators, but again, we have a longer lifespan but fewer offspring. So we're limiting essentially like how many offspring are made, that there's not too many to compete for the resources for those that are still surviving and reproducing. So that could be a bad deal if you overproduce. These are controlled by density-dependent factors, as we talked about before. So this next little segment is talking about threats to biodiversity. And ultimately, the number one threat to biodiversity is essentially us. There are many threats out there, don't get me wrong, but we as humans have had a profound impact on our environment, whether we want to admit it or not. And sometimes we inadvertently have impacts and we don't even know it. And that could be like trash, garbage, things like that, sound, light pollution, and we don't even know these things are happening, but yet we are having an effect on the species. So let's explore some of these concepts here in threats to biodiversity. The main idea: people are using many approaches to slow the rate of extinctions and to preserve biodiversity. We've started to realize we are having great impacts, and we are trying to take steps forward to preserving other life out there without damaging it to the point where they go extinct. To understand the concept of extinction, that is essentially there's background extinction, which is a normal process in an ecosystem as the ecosystem changes, succession. So we talked about how there's primary succession and secondary succession with plant life. That things move in, they're replaced by, the grasses are replaced by shrubs, and shrubs are replaced by saplings and trees, and over time we get some pine trees, conifer trees, and then we get mature trees like oaks and hickories. That's a natural change of things. There is a natural change of species throughout history, that they slowly but surely change and adapt to the climate changes, the environmental pressures, whatever they may be. It is a very slow process that allows organisms time to adapt. And we mentioned this in the range of tolerance, that yes, there are some that are physiologically stressed and that they're under pressure, but if they can survive and continue to survive in those conditions that change gradually, they can ultimately change the entire species if given enough time. There's also mass extinction events that we also mentioned with the dinosaurs, an event in which a large percentage of all living species become extinct in a relatively short period of time. So just like the meteorite hitting the Earth, wiping out a bunch of them, but then also the events afterwards wiping out a bunch. So it did take quite a bit of time to wipe out many of the dinosaurs, but in the time frame of Earth's history, it was very small. So when we think about what causes threats to biodiversity, it's a lot of times it's the resources. And sometimes these are natural resources that exist. They could be water, air, soil quality, minerals, fossil fuels in our case that we use for energy production, keeping our homes warm and cool, nuclear fuels, plants, which are crops essentially, animals, cows, pigs, chickens, things like that, but all sorts of things that keep you alive. All those things can limit a population in different ways. The number one threat to the majority, as we talked about, is humans or just Chuck Norris. In the past, though, what we've done is called overexploitation of species, excessive use of species that have economic value. So it could be beef, it could be furs and things like that. This also could change like habitat loss, destruction of the habitat in which they live in, urbanizing it, changing a grassland into a forest, disruption of the habitat, just simply being there, or introducing new foreign animals like cows or pigs that could disrupt the deer or salamanders or frogs in a pond. The fragmentation of habitat, putting up fences and things like that, can all do that. We've actually created a problem for black bears in Missouri by fragmenting their habitat, which they like some undisturbed areas. Pollution itself, where they can live and where they can't live, whether the streams or the ponds or just the environment itself. And even introduce species that outcompete them for resources because they have no natural predators, they grow large in numbers, and they just consume everything. Some examples of our overexploitation would be like bison. They once numbered 50 million. By 1889, only about 1,000 were left. You can see a picture of a bison on the right. On the bottom right picture, that, just to give you frame of reference, is a guy standing on top and a guy standing at the bottom, and that is a large amount of bison skulls. So, yeah, we pretty much destroyed their population. When we built the railroads, people got bored on the railroads, so they'd take their guns with them, poke them out the windows, and they would shoot the bison as they rode the train. They didn't stop the train to pick up any of the bison meat or furs. They just shot them to kill them and leave them lay. So you begin to realize that, yes, we were causing problems for the environment long ago, too. Passenger pigeons, these guys once numbered like in the millions. There were so many of them that they were rumored and documented that when they'd fly over in the sky during the daylight, they would turn day to night. That's how many of them there were. They would fly over and people hated them because they would just like poop on everything. It was literally a poop storm coming, and they'd just coat everything and they just keep on going. But people found out they were like chickens. They were pretty tasty. So if you killed them, you could eat them. It was fantastic. It became a big business. People would wait for them to roost in these trees. And keep in mind, there's so many of these little pigeon birds, which pigeon birds are pretty light. There were so many of them that they would snap the branches on a tree because of all their weight. That's how many there were. They would set up nets and funnel them into nets and beat them over the head with shovels and then literally scoop them in the back of dump trucks and then take them into the city to sell. So, again, we got down to 2 left in the ecosystem. 1 male, 1 female. We're like, woohoo, we can save the species. Turns out he was the ugliest bird you've ever seen in your entire life because she wanted nothing to do with the guy. Ultimately, though, a scientist was like, it's not going to work. And they're like, why? He's like, I've done extensive research. It turns out the only time they know when to mate is when they're in large groups. So, only 2 left. It wasn't going to work. Ocelots, those are kind of like cats. They have a very fine fur and stuff. They were hunted for the furs, almost to extinction. The white rhino, the horns, stuff like that. Prize hunters and things like that just to kill them. Okay, so just stupid things over time. But beyond just killing them, we kill them in different ways with like habitat destruction. The clearing of a tropical rainforest destroys thousands of species. That 1 acre may be home to just one particular species, and now we've destroyed it. And that's a problem. Disruption of the habitat, fishing the oceans. There's lots of whales, sharks, dolphins. They're all fishing for the same thing, and we catch them in our nets. And a lot of those species get caught, and then they get caught in the nets, and they have to kill them. So they die. So we're really affecting the ecosystem far greater than we realize. One of the biggest things we're doing now is called the edge effect. We all want to live in our nice little house. We want to live on the outskirts of town. We don't want to live in some big high-rise with the neighbors that we can hear above us and below us and are all around us. We'd like to have our own house, a nice piece of quiet. So we call this urban sprawl, where the cities start to sprawl out and we get these nice little communities. And we're not too close, but yeah, we're still a community. But this starts creating the edge effect. As we start bisecting it with roads and homes and things like that, we create these edges within the nice forest or the grassland area. The species that grow on the edge versus the middle are totally different. Some species require the foundation of a forest that's, 10, 20, 30, 100 acres, okay, whatever it may be. And now we cut it down to less than a half acre. Yeah, it's got some trees and it's classified as a forest, but is it really? You're starting to create this edge effect of other species within it. So we got to think about how we manage our land too. As we do that, we also think about our industry and how we do things. So pollution can get in the environment and affect them. We don't always see this pollution, but it can be there. There's acid precipitation, acid rain. We started realizing that a lot of our factories were producing a lot of smog, contaminants within the atmosphere, and it's coming back down within the rain. The precipitation is getting converted into acidic solution, and it was killing the leaves on trees, burning them up, essentially making them look brown during the middle of the summer when they shouldn't have been. So the vegetation was dying. They started noticing corrosion on statues and cars and things like that in buildings, and they're like, well, this is pretty bad, that we need to do something about it. So they enacted the Clean Air Act, which actually cut a lot of these emissions when it actually did help. Eutrophication, the excessive algae growth that uses up all the oxygen, suffocates organisms in the water. This can also release toxins or red tide. There's parts of the ocean in the Gulf, right around Louisiana, where the algae grows and then it dies. And when it dies, it's eaten up by bacteria, and the bacteria consume all the oxygen in the water. There is no fish, no mussels, no clams, nothing that survives in that area because there is no oxygen. Fish literally can't breathe in their own water. It's kind of crazy. There was other pollution that we started mentioning about DDT. DDT was a chemical that was used to kill off insects. Worked really well for killing insects, but due to biological magnification, it started building up in other organisms like fish. And those fish were eaten by eagles. Eagles ate them and built up the toxins. Didn't kill the eagles per se, but it made the eggshells of the eagles thinner. So much thinner that when they sat on them to warm them up, they actually crushed them, which meant no new baby eagles. So the American eagle, that is the symbol of our nation, almost went extinct because we wanted to get rid of insects. And we refused to accept this. Rachel Carson, she was an author and an advocate for conservation and the protection of the environment, wrote a book on this, exposing the deadly truth, that the U.S. government was actually behind some of this, funneling money to this company to help get and eliminate the insects. And ultimately, she got DDT banned in the United States. DDT is still used in other parts of the world, though. So, a lot of pollution out there. Another crazy thing is called introduced species. Species that are not native to the ecosystem. Some intentionally were placed there and some unintentionally placed there. And they begin to outcompete native species. And it can be very, very extremely difficult to control. Zebra mussels in the state of Missouri are a huge problem. They actually came from Asia, like around Russia. They have natural predators there, but they hitch rides on boats and cargo ships and things like that, and they eventually wound up in our fresh waters. So as a result, they're now multiplying and growing and dividing constantly in the United States. Many of our lakes and stuff have signs that said, help stop the spread of zebra mussels, that you have to power wash your boats and stuff like that, inspect them. And we write fines and tickets for people that have them on there and they're attempting to back them into a water. This can cause water treatment facilities millions of dollars by clogging up the intakes. These little guys like to stay where there's moving water. A pipe that's constantly sucking water out of the lake into a water treatment facility is the ideal location for them. So we're trying to help stop those spread so they don't outcompete native species and stuff like that. Another big one is the pythons in the Everglades of Florida. These people had some pet snakes. They didn't want to kill them. They thought, well, we'll just release them back in the environment. These snakes didn't come from Florida. They came from South America. And turns out Florida has the right ideal temperatures for them, and they grew and they survived. and everything was good. And now they're becoming an apex predator, eating even some of the gators, the smaller gators down there, limiting their population. So we're starting to see huge problems all around. Okay, last couple things here that we need to discuss, which is conserving the biodiversity. So what are we doing to help correct this problem, solve this problem? Main idea, people are using many approaches to slow the rate of extinction and the preserve of biodiversity. So again, like I said, Rachel Carson got DDT banned. So we're starting to realize there's chemicals we can use and chemicals we should not use in our environment. There is a difference between conservation and preservation. Conservation is maintaining species and habitats as resources for later use. So you are going to use them, you're just going to use them wisely. It's not that we're going to cut down the entire forest and use it all for firewood. We're going to cut down a little bit here and there and let some grow back. Make sure that we replant things so that we can have future generations. So preservation is essentially just setting land aside for a particular ecosystem which has no use. We don't touch it. We just leave it alone. It's a nature preserve. Animals can go live there undisturbed by human activities. When we think about even like our Long Branch Lake, we have parts that you can actually duck hunt on, and there's parts that you can't duck hunt on. So they're trying to preserve some of that land for the ducks as they migrate southward, but yet still opening up some of it for hunters. Natural resources. We have to be wise with what we use. So materials and organisms found naturally in nature. Types of natural resources, renewable, which means these are things that we can replenish within your lifetime. Okay, that they can be consumed, but yet we can regrow them again if we need to. That could be like corn. We use that as a renewable source of fuel, like ethanol. A non-renewable source is something that does not get replenished within your lifetime. Okay, something that takes millions of years, like coal, oil, and natural gas. And again, we still use those non-renewable resources, but yet, again, some of those prices that you're paying at the pump, you're like, oh man, it's a lot of money. It's a non-renewable resource, so it's in limited supply. Another concept that people have been talking about is sustainable use. Using resources at a rate in which they can be replaced or recycled while preserving the long-term environmental health of a biosphere. I used to watch the show called Axemen. And it was really interesting because one episode, like all these guys do is log trees. They cut them down out there in like Washington area, and they're just constantly cutting trees down. And then there's one episode where the guy's like, this is the favorite part of our job though, where we go back out and we replant trees. And I was like, that's kind of cool. They don't really talk about that a whole lot. But the reason why they liked it so much is they said that they can plant all these trees again, in 20, 30 years, that maybe, their sons or daughters will take over the business and harvest the trees that they planted. So they were being sustainable and trying to replenish the ecosystem and create some revenue for themselves in the future. So they really liked giving back to nature as much as, they were cutting it down. They wanted to help, again, rebuild it, which is kind of cool. There are reserves. About 7% of the world's land is set aside as some type of reserve. The United Nations supports a system of biosphere reserves and World Heritage Sites. The United States is one of the few nations, believe it or not, that has set aside lots of their land as national parks, state parks, and conservation areas. We have lots of areas to go to. Lots of people from other countries like to come to the United States and explore these awesome, cool areas that we have set aside. And the reason why they come to the United States to look at it, all these cool areas, is because their country doesn't have it, which is kind of cool that we have these things for you. So get out and explore them. Current applications, corridors between habitat fragments to improve the survival and biodiversity by providing corridors or passageways between habitat fragments. They're building like bridges which are covered in dirt and grass so that deer and tortoises and turtles and snakes can go across them. Not for cars, but for other animals, so they can go across and not get hit by them, by cars and stuff like that. Restoring ecosystems, conservation efforts, EPA regulations, and DNR. We're trying to bring back what is damaged, what has been damaged, and bring it back to what it was before by setting these regulations. Not everybody agrees with them because, again, they can inhibit businesses and stuff, but we have to make an honest attempt to make sure that we're restoring everything that we can, because we live in this environment and we're not alone. Other ones that we're talking about for current applications is bioremediation, the use of living organisms such as prokaryotes, fungi, and plants to detoxify polluted areas. Turns out a lot of nature can correct itself if you put the right things in there, if you give them the right chances to survive and live. So using living things to clean up the environment, not more chemicals. More chemicals can just add more problems. But if we use natural things, we might be able to get the job done. Biological augmentation, adding natural predators to a degraded ecosystem. If we've removed natural predators and things like that, and there's a problem of other producers or primary consumers moving in, and they're just overpopulating, we can reintroduce some natural predators. It's not always the ideal thing, okay, because people might be like, oh, I don't want that to happen. But a moose population can get overpopulated. Elk population can get overpopulated. So they say, let the natural predators take care of them if we can't hunt them fast enough, which includes things like wolves or mountain lions. We get a little skittish when we know that there are things out there that could potentially harm us. But again, the ecosystem is not just ours, it's everyone's, which is all the species. Okay, so that's all we got for today. I just wanted to go over some applications because they will ask you to think about how, you'll see how we are making steps or progress to correcting the ecosystems that we've damaged. So what can we do to solve some of these problems? And moving forward, you got to think about, why do we have the conservation? Why do we have the DNR, EPA? And again, it's not necessary to set restrictions to hurt businesses and stuff like that. It's again for long-term sustainable ecosystems for all species to survive. Because if they go extinct, how soon is it before we go extinct?